This is the latest iteration of my remote pressure tuner for double-stack solar telescopes. The source pressure from the air compressor enters a T which provides the pressure to two miniature pressure regulators, one for each etalon. The pressure regulators reduce the source pressure to values that are controlled by turning the knobs on top to output anywhere from 0 to 15 psi, which goes to the etalons to tune the hydrogen alpha bypass. So the two etalons can be tuned completely independently of each other. A digital pressure gauge is threaded onto each regulator to give continuous reading of the pressure on each etalon. This allows returning to known optimal pressure tuning values. The all-threaded design makes for a rigid, durable assembly. I also designed a 3D printed box for holding the pressure tuner assembly, which can be downloaded for free from thingiverse.com. The pressure tuner knobs drop into the holes in the box, and the 3D printed mounting nuts are used to secure it into place. The box uses 7 heat-set brass-threaded inserts to attach the 3D printed cover plate. The inserts are pressed into place using a 15-watt soldering iron to soften the plastic. Flathead number 832 machine screws are then used to secure the cover plate. The assembled box makes a neat container for the pressure tuner at very little cost because you print it yourself. Now I'll demonstrate the remote double-stack pressure tuner. The air compressor is supplying a constant 30 psi. First, I turn on the two pressure gauges, which initially read 0. Then I start turning up the pressure on the single stack etalon, aiming for a pressure of about 11.3 psi, which I have found to be optimum for my telescope. The image darkens dramatically as it comes on band. 7, 8, 9, 10, 11, and we're about there. Then I increase the pressure on the double stack etalon and the image brightens back up as it comes on band around 13.3 psi. Again, that's the optimum for my telescope. 7, 8, 9, 10, 11, 12, 13 psi. The optimum pressures for the two etalons could be different for different telescopes. Now there is lots of detail visible on the surface. And if I increase the gamma, we can see prominences visible here, 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 and here. I'll return the gamma back to where it was. So this unit allows me to remotely tune the two etalons independently to the optimum pressure for each. The pressure gauges allow me to reliably get back to the sweet spot for each of the etalons. And the pressure regulators will maintain the optimum pressures to about plus or minus a quarter of a psi indefinitely, allowing long-term time-lapse imaging.